Well, well, well. Hello there, boys and girls. Got a pretty interesting lesson for you today. This is one that's going to be like massively important as you move forward in math. We're going to do a little bit of kind of feels like trickery. What we're going to be doing is we're going to be solving some equations where the unknown is actually an exponent, and we're going to do this in a way that's kind of cool to me. Now, this topic does come up later in more advanced math where you can start using logarithms and all those kinds of things. But in our level of math, what we're going to be doing is we're going to be doing something where we're going to get the bases to be the same because if the bases are the same, then the exponents also must be equal. See how this says equal, right? That means that everything over here has to be everything equal to everything over there. Now, we can't actually use inverse operations to solve this, but what we can do is if we can make this a 3 and it's equal to that 3, then those exponents must be equal because that's the only way it can be equal to each other. Now, let's take a look at this one right here. You can figure this one out. 3 to what power is 9? Well, x must be 2, right? That's the only thing it could be, because, right? Well, let's try our little trick right here. Since this can be rewritten, oh, right there, that's true, right? 9 is equal to 3 squared. Those two things are equal, do you see? So, because 3 to the power of x equals 3 to the power of 2, x must be 2. That's how you're going to do it. Here, when we came up with this x equals 2 right here, we just figured it out. 3 to what power is 9? 2, right? But let's say you couldn't figure that out. What would you do? Well, you would do just that. Let me give you another example. Let's say that we had 4 to the power of 2x equals, oh man, let's say 32 to the power of x plus 1. Let's go ahead and explore this one right here. Now check this out. This one's kind of tricky because 32 is not a power of 4. Like the one we did here, 32 was, or 3 was, or 9 is a power of 3, 3 squared, right? But they're both powers of 2, so that's the trick you got to remember. See, would you agree with me that 2 squared is 4? So all I'm doing, I'm taking that 4 and rewriting it to the power of 2x. And then 2 to the power of, I think it's 6, right? Let's see, 2 times 2 is 4, 8, 16, 32, 5. 2 to the power of 5. All right. So that's 2 to the power of 5, x plus 1, right? Let me double check that again. 2, 4, 8, 16, 32, 5. Yeah, 2 to the power of 5 is 32. So now check this out. Do you see how I've got 2 to some exponent equals 2 to some exponent? Those exponents must be equal. So now all we got to do is use the thing we know about exponents. Raise the power to a power. You multiply. Now here we have to multiply 5 times that whole thing. That's 5x plus 5. People always write plus 1 right there, not plus 5. You have to multiply that 5 by both of them. This is the exponent, x plus 1 times 5. So now, what we've got is this kind of situation. See, the bases are the same, and it says that it's equal, so that means the exponents must also be equal. So what we got to do, get the x's on one side. I'm going to subtract 4x from both sides. And at the same time, I'm going to subtract 5 from both sides. So negative 5 equals x. There we go. Let's check that. Let's see. Negative 5. Let's see. 4 to the power of negative 10. Because if I put negative 5 there, right? Oh, that's a really, really small number, right? Let's see. 1, 2, 3, 4, 5, 6. 6 and then 6 zeros and 0.95. So that'd be like a 9 times, right? Okay, let's try the other one. Let's do 32 to the power of negative 4, right? Because if I put negative 5 there, negative 5 plus 1 is negative 4. Holy moly, same. It did work. Who knew? All right, so here's the big idea. You have to manipulate those bases to make them equal. So this and this, you need to write them as the same number. Substitution is what we're doing right here. So like let's say here, well here, let's get into this one first. Let's get into this one first right here. This one's kind of tricky. You see, I can't multiply those together because of the exponent. That makes things kind of tricky here too. But here's what I'm going to take a leap of faith with. I'm going to say I can rewrite all of these as 2. 2 to the 4th, that's 16, right? So this is 2 to the 4th. So I just rewrote that 16 as 2 to the 4th. Equals 2 to the 1. We're good there. And then, would you guys agree with me that if I said 2 squared is 4? Ah, yeah, look at that. So this is 2 to the 4x. I got that. Now check this out. Bases are the same. They're both 2. And we're multiplying, so that means we can add those exponents. Oh, man. But first, I got to take care of this. Oops. 2x minus 2. You see that 2 I have to distribute to everything in there. Now I can add those together. So I got 2 to the 4x equals 2 to the 2x minus 1. Alright, because this is 1 plus that. You have to add those exponents together. So you have to add those things together. That's how you get this right here. So now, bases are finally the same. So 4x equals 2x minus 1. So 2x equals negative 1. X is equal to negative 1/2. Man, that's fancy right there. That is fancy. Let's try this one right here. This one's a little simpler. In fact, I want you to try this one. Rewrite this. I'll give you a clue. Rewrite this as as 3 with an exponent. And then try to solve it. Go ahead. Is that what you got? So now we have to multiply these together, right? 3 times x over 3. So 3 over 1 times x over 3. Isn't that just equal to x? So this is 3 to the power of x equals 3 to the power of 2x plus 1. Bases are the same. Set those exponents equal. Negative 1. Dang. How you guys doing, bruh? Hope you're doing good. Have a good day. I'll talk to you soon.